Okay, today we're going to be talking about some quadratic word problems. So there's a bunch of different situations that you can use quadratics in the real world. It's usually stuff that involves maximizing or even minimizing space. Okay? Some of these can be kind of difficult to figure out, but once you figure out the quadratic, it's generally pretty easy. Again, it's kind of about reading the problem and understanding what it's asking. My advice with these is to always draw a picture to kind of visualize what it's trying to get you to find. Okay? So, let's start with this first problem. The maximum size envelope that can be mailed with a large envelope rate, which is when the length is 3 inches longer than the width. The maximum area is 180 inches. Find the length and width. So it's wanting me to figure out what the maximum size of an envelope is that can be mailed with a large envelope rate. And that means that the length has to be 3 inches longer than the width, and that it has an area max of 180. So let's draw a picture here. So here's my envelope. There's my little, that's my envelope. It's a great envelope, right? So it says that the area of this envelope has to be 180. And that the length has to be 3 inches longer than the width. So if this is my width, then the length would have to be the width plus 3 inches. Okay? Now, how do we find the area of a rectangle? You take your length and you times it by the width. So we would set this up as W times W plus 3, and that would give me my area, which has to equal 180. That would be my maximum size, right? Well, this is a quadratic, right? Because if I were to multiply this through, I would get, W squared plus 3W equals 180. Okay? Then, in order to do the quadratic formula, if we want to use the quadratic formula, we have to get it equal to 0, right? So we'd minus 180 to each side. And that sets up a quadratic of W squared plus 3W minus 180 equals 0. Now, I use W, in case you guys are wondering, because it's for width. You can use whatever letter you want. It's a variable, right? You'd use a smiley face there if you wanted. Okay, but in order to use the quadratic formula, I need to find my ABC now. So I'm going to find my ABC, and you're going to see why this makes sense here in a second. So A is going to equal 1, B is going to equal 3, C is going to equal negative 180, and then I set up my quadratic formula. Quadratic formula is negative B plus or minus the square root of B squared, which would be 9, minus 4 times A times negative 180, so negative 4 times negative 180 is positive 720, so I'm going to add 720 here, which would be 729, all over 2A, which is just 2. So, that'd be all over 2. So 9 plus 720 is 729, square root of 729 is 27. So I'm going to have negative 3 plus 27 all over 2, and I'm going to have negative 3 minus 27 all over 2. Now, negative 3 plus 27 is 24. Divide by 2, you are going to get 12. So x is going to equal 12. Negative 3 minus 27, all divided by 2, is going to be negative 15. Now, can you have a measurement of negative distance? No. So that one doesn't work. But this does, so this can represent my W. So if I plug it back in, that means that my width is going to be 12. And my length is 3 inches longer. 12 plus 3 is 15. So the length would be 15. So the dimensions of that envelope would have to be 12 by 15. Okay? But that would be my answer right there. Not too tough, right? This next one's going to be a thinker. So, a rectangular garden is 30 by 40 feet. Part of the garden is removed in order to install a walkway of uniform width around it. The area of the new garden is 1/2 the area of the old garden. How wide is the walkway? Okay, so again, drawing a picture helps with all these so we can kind of visualize what it's saying. Okay, so my original garden was 30 by 40 feet, right? So a rectangle. We're going to install a walkway all along the perimeter that has a uniform width. That means all of these are going to have the same width here, right? And we'll call that W again. Why not? Okay. Then it also tells me that I have an area that is 1/2 the area of the old garden. So to find the area, it's 30 by 40, right? So I do 30 times 40. You guys can talk.
What?
Which is 1,200. So the original area is 1,200. So half of that would be 600. So this new garden is only going to have an area of 600 feet squared. That is in feet. Okay? So, when we look at this, since all of these are the same width, basically I am taking the width off of each side, right? If I'm trying to find the area of this new garden, it would be this number minus the width, right? Because I took the width off of each side here. So if I wanted to multiply to get to 600 feet, I know that 30 minus the W times 40 minus the W is going to equal 600 feet. Now, next step would be to kind of turn this into quadratic so we can solve for our maximum space here. So we're going to just distribute everything. We're going to distribute the 30. We're going to distribute the W. We're going to get 30 times 40 is 1,200. Okay. Then 30 times negative W would be negative 30W. Negative W would be negative 40W. And we would get plus W squared equals 600. So we're going to combine our like terms. We're going to get, and I'm going to reorder it so it's in the normal form. So W squared minus 70W plus 1,200 equals 600. Still not quite there. We need to move the 600 to the other side so it's equal to 0. And we're going to get W squared minus 70W plus 600 equals 0. Then our next step is to use our quadratic formula. So A is going to be 1, B is going to be negative 70, C is going to be 600. So we're going to plug that in. We get negative B would be 70 plus or minus the square root. 70 squared, technically negative 70, but it doesn't matter. 4,900 minus 4 times A times C. So negative 4 times 600, negative 2,400. And then all over 2A would be just 2. Okay, 4,900 minus 2,400 is 2,500, which when you square root that is 50. So we have 70 plus 50 all over 2. And 70 minus 50 all over 2. Well, 70 plus 50 is 120, which would give me 60. So 60 is one answer, and then 70 minus 5 all over 2 would be 10. So 10 would be the other. Now, this gives me 2 possible answers, but one of them is not going to work. And again, we're going to consult our picture here to see what makes sense. So if I'm looking at the length of the walk or the width of the walkway, would 60 feet make sense for this width? this length is 40. Does 60 make sense there? No. But 10, if I look at the width, it's happening twice, right? If I look at 10, I'm basically taking 10 away from each side here, right? But the actual width would be half that because it's happening twice. So my actual width is going to end up being 1/2 of this answer. So the width is actually going to be 5 feet. Okay, that one's a bit of a thinker, and again, drawing the picture helps because you'll notice while we got 10, if I did 5 plus 5, that would be 10, right? So we had to make sure we looked at our picture to see why 10 worked. Okay, one more to do. This one again is a bit of a thinker. So find two numbers that differ by 8 and have a minimum product. So minimum is talking about, when we talk about a parabola, it's a vertex, right? And it's an open facing vertex or parabola, so it's going up. This would be a minimum right here. Okay, so I need two numbers that differ by 8 and have a minimum product. So that means when I multiply them together, it would become the minimum. Okay, so when I have to set this up, it's basically saying two different equations here, right? Two numbers that differ by 8. I'm going to say A is my first number and B is my second number. Okay, so when it says it differs by 8, it's saying like A minus 8 would equal the second number. Okay, it's also saying if I multiplied them together, it's going to equal the product or minimum. So I'm just going to call that P. Now what I'm going to do is I'm going to use substitution. This is like a system of equations. I'm going to get, well, the B is already by itself, so I'm going to take what B is equal to and I'm going to substitute in for B in this other equation. So B is equal to A minus 8. So I'm going to rewrite this. I'm going to take this. I'm going to substitute it in for B right here. So I have A times A minus 8 is equal to P. Now, the P is, now we're going to kind of set up a quadratic formula here a little bit. So I'm going to distribute the A. It gives me A squared minus 8A equals P. And I could subtract the P and everything to get everything to one side. But all I really need in order to find one of my numbers, because again this is talking about a minimum, is I need to find the axis symmetry. Find the axis symmetry, I just need the B and the A, because it's x equals negative B over 2A. So the negative 8 would be the B, so it would be positive 8, and A is just 1 over 2 times A, which is just 2. So A divided by 2 is 4. So I am going to get 4 for one of these numbers. Now, next thing I'm going to do is I'm going to take this, plug it back in for A into this equation right here, and it's going to give me the other number. So if I plug it back in, I would get 4. Do I have to do that one? Oh, I can plug it back in this original one. 4 minus 8 is negative 16. That's going to give me the product, right? Yeah, oh, sorry, I'm over here. So, sorry, I'm getting lost where I'm at. I want to use this formula right here. So I'm going to plug in 4 for A. So 4 times 4 minus 8 equals P. So when I distribute that, I would get 4 times 4 is 16 minus 32, which is negative 16 equals P. So that gives me the P. Now I know that A is 4, P is negative 16. I'm going to plug it back into this equation right here now, and I'm going to get 4B is equal to negative 16, which you divide by 4, and B is going to equal negative 4. So my new two numbers are going to be 4, and they're going to be negative 4. And that is how you do it.